Hello everyone. I will just start by saying I'm coming a little bit from the future if I look what Tim is saying. Because what I will present to you now is one of the projects we have deployed where we have a blockchain involved with one of our customer, NG, in the green certificate generation and how to ensure the origin of energy based on blockchain and on oracles reading information from the field. You do not have the...
So it seems that we need some more blockchain in there. The file seems to be damaged, so
Yeah, but
just
I
one quick
can
minute.
start, yeah.
Yeah, sure.
I can start just presenting Ledger because for some of you, maybe you know us, but for some of you, it's new. Ledger is a company that has been built in 2014, sorry. We are now around 200 people in the company, and our main business at the moment is how to protect your assets when you are buying cryptocurrency, like the Bitcoin, like Ether, like all these hundreds of cryptocurrencies that is existing today, and how to ensure you that when you are buying this cryptocurrency, your assets are secure and your money also are secure. And for that, we have developed what we call an hardware wallet, where we store all the keys, all your reference or your identity in order for you to be able to buy cryptocurrencies and to be sure that those cryptocurrencies stay yours. This was our original business, and we have moved in now two additional directions, which are moving to the bank, supporting in fact the bank in this kind of managing also cryptocurrencies and give them the possibility to buy cryptocurrencies, but with some level of hierarchy, meaning you cannot have only one people buying cryptocurrency without having some validation from manager, from this kind of things. And this is the second B2B business we have opening. And the last one is IoT. And our goal in IoT is really how to secure the IoT and also how to use blockchain in this IoT in order to ensure the data you are generating from the field and to ensure that this data is the right one, is generated from a device you are able to identify and store for in the blockchain in order to be public or private, depending how you will use the blockchain, but in fact to use blockchain as a way, in fact, to store this data. Okay. Let's go. My presentation, I will have, in fact, a part about hardware oracles and security provided by these hardware oracles, and also use cases and current deployment we saw, in fact, today on this technology. I will go fast on that. It's just to give you some figure about the company. As I said, created in 2014. We are now located around the world, and we have sold, in fact, 1,500,000 hardware wallets in order to secure cryptocurrency assets from end user. As I have said, we have three different business today. The hardware wallet on one side, the bank in the middle in order to have multi-authorization business grade, and the IoT, which is where we will focus today. IoT is clearly end-to-end security solution in order to get data from the field and to ensure that data is the right one when we are retrieving it. For this, I will present you the use case about green energy. Just to start, as I say, I'm a little bit from the future because this registering green energy production securely in energy blockchain is today a reality. It's a project we have deployed with our partner, NG, with a real blockchain called Energy Web Foundation based on Ethereum in terms of blockchain in order to register the production of energy coming from solar panel, for windmill, from different water plants, for example, and to prove that this solar panel or this windmill is producing energy. And we have an hardware, an oracle, in fact, on each part of the system in order to ensure end-to-end security and the information. Engie sell this information to its customer in the way that their customer buy green energy, and Engie, to prove that to their customer that they are buying green energy, deliver them certificates where this certificate contains the information from the blockchain where it's proven that it's green energy. Just to be back on the energy market exchange, today on this market, we have, in fact, the transport part of the energy, the production part, and the distribution. And all that we can easily connect in order to any blockchain in order to prove that an energy producer is doing the right thing in terms of producing energy. The consumption on the other side, which is the consumer or an industry, is consuming the energy, and you can prove also that the level of information they have produced or they have consumed are registered in the blockchain. And in the same time, you can exchange information between all the actors during all the process from production to consumption. You are able to track in the blockchain the information to check the value of this block of the information of the block in the blockchain, sorry, and to be sure at the end that you are buying or you are consuming green energy. This is not so far from what has been designed based on certificates by the EU. I will back to that after. Some regulation today have put in place some mechanism in order to prove that you have produced green energy. You have to go to some entity in order to receive a paper certificate that you have done this kind of production. What we are proposing with Ledger is in fact to do that automatically and to use the blockchain as the proof for the certificate. How it's happening, in fact. You see from the source, the production part, we have an oracle in the middle that is in fact measuring the production of green energy directly on the field near the production part. This energy, in fact, we can imagine in the future to send it to a guarantee of origin issuer as it has been defined, for example, by EU in the current regulation. And this guarantee of origin issuer will provide certificate that will be registered at the end by the system inside the blockchain. You see here, I have put the Energy Web Foundation logo because this is the company we are working with at the moment. But whatever the type of blockchain, whatever it's a Tangle or public or proprietary blockchain, it can be possible, in fact, to register from the oracle on the field the right information and to create a certificate in order to deliver it to this blockchain. On the other side, you see that all the people which are classic in the energy distribution can have access to the blockchain, can read information from the blockchain. And for example, Engie, in this case, can sell this certificate, this electronic certificate, to any people that are buying from them the green energy. And it's an end-to-end solution where they are producing, selling, trading energy. And if we extend the use case to, for example, many countries, we can imagine to have a center place where we register green energy and where people can trade this energy, can exchange this energy, buying from this blockchain. And at the end, when you buy something from the blockchain, you know that this block is your energy. It's what you buy from the blockchain. And you are able to prove that your company is only consuming green energy. It's also proving that only you can consume this production, which is important in the way that we don't want to sell 10 times the same block of energy to 10 different people. No, it's not possible, because with the blockchain, you have one immutable data that is proving you are the only one buying this from the blockchain. Just to be back to some discussion we have previously, in fact, in the blockchain, we are registering token, and these tokens are registered through smart contracts. Smart contracts, even if sometimes it's complex, it's just a basic system that authorizes you to register information in the blockchain if you have the right to do it and if you are recognized to do it. For example, in our case, we as Ledger are able to register information in the Energy Web Foundation through a smart contract, and the smart contract is checking who is registering information, listing the different oracle on the field that want to register information, authorize them to register information. And it's the same in the other way. Through the smart contract, you can get information from the blockchain, and you can be identified as the one being able to retrieve from the blockchain. If we go deep in the architecture, and it's where I want to say, from the beginning, we said that blockchain, it's trust. Yes, but only if you ensure from a software and an hardware point of view that your information is secure from the beginning. This is why in our deployment with NG, with our customer, we are getting information from the field with this hardware oracle. Within this hardware oracle, we have what we call a secure element, which is the same kind of chip you have in a banking card, meaning it's a very secure chip, resistance against attack, whatever it's physical attack or whatever it's attack through the web, for example. And this sensor, in fact, this secure element get information from the sensor, secure it, and after transmit it. When the information is leaving this hardware oracle, the information, you cannot modify it. You can prove the origin of the information, and this information is secure. Yeah.
Regarding the Oracle engine, you say it secured the information from the origin.
Yeah.
But does this Oracle have a kind of protocol consensus? So how the Oracle is going to decide that the information from the origin is authentic? So what's the protocol behind the consensus? Is there a consensus protocol? It's just a network security. So this is not clear to me.
No, it's physical security in the way that this sensor, for example, in the case of NG, the sensor is directly connected to the secure element, and the information is retrieved directly inside the secure element, meaning that no one can modify the information you received. We have a mechanism, in fact, to protect the system in order to prove that when we install this oracle, it's the right one sending information from the right site. And after, in the way we are sending information outside of this oracle, we have secure channel, in fact. But all the information are managed within, as I say, a banking card or an ID card inside the system in order to retrieve information and in order to be able to send it securely to the blockchain to be registered in the blockchain.
I would like to have a follow-up question on this, because I think this is really the crucial point of the system. How does the sensor really know that's green energy? And so I imagine the sensor may measure the amount of energy.
Yes.
So how does the sensor know that this is really coming from photovoltaic source and not from nuclear energy, for instance? Because the electricity is the same in the end.
This is where we are really working with NG and where we will, in fact, work with all the regulation around that in order to ensure this we need at some time when you deploy this oracle to ensure that this oracle is in the right site. And for that, it's through audit, it's through mechanism that physically you have someone putting this oracle in place and certifying that this oracle is the right one.
But I mean, if I in the end have to trust this one person that witnesses this hardware sensor has been installed properly on a site that produces green energy.
Yeah.
So this person for me is the weakest link. And if we have such a weakest link that is one person of certifying the green energy, why do we need the blockchain then? Why cannot we directly then also trust this person to put the data in the internet without a blockchain?
The point clearly, yeah.
So I think that's a very good question, and I think that's exactly the kind of things that we want to surface in this workshop.
Yes.
And if I understand correctly, what Ledger is presenting here is an end-to-end solution that solves a particular problem with a range of technologies and physical security measures. In that whole construct, the blockchain has a role, which is mostly to prevent double spend. That's the purpose, right? So the purpose of blockchain here is to prevent double spend of digital objects that are created by this physical infrastructure. Everything else relies on other types of technologies and other types of measures.
If I may follow up on it and sort of follow with a question, I think the answer to your question how blockchain could be used in this case is that it enables gathering of data which can serve for indirect confirmation that this energy produced came from renewable sources. For example, tracking weather patterns with the production of the wind farm and so on. And I think that could be actually the sort of like an opportunity for the next step in developing this platform. And that would be my question. What do you expect? Where do you expect to go next with this existing platform and the product, and how do you intend to develop it?
Yeah. As you say, the point is, first, when you install it, you have to trust the people that will install it. And what is the next, in fact, is to be more, by default, include in the system. Because today, this oracle, it's an additional device we put, for example, on an electric meter. And based on this electric meter, we are able to retrieve the information. If we include it directly in the electric meter, we solve part of this issue because we are not able to remove it, to change the position. You do not need to install it. This is where we need, for example, to push this idea of having this kind of automatic registering of energy within the electric meter. And it's something next we saw today, because we are able to deploy this technology on the current electric meter with some limitation, as you highlight, the human that is able to put this on a power nuclear plant instead of putting in a windmill. But if I just compare it today to what is done about this guarantee of energy, today it's self-declaration in front of some company that you are producing in this site this quantity of energy, and this company is doing the same. They go to do an audit to check that you have the right level of capacity to produce what you declare. But at some point, it's a trust between humans. And here we are increasing the system, but by having this automatic mechanism to declare the quantity of energy that has been, in fact, deployed. As I say, what is really important is that the information leaving the oracle and leaving the secure element inside the system must be immutable and must be locked. Meaning that whoever catch it when it's leaving the windmill, for example, you have no possibility to change the content of the data, and you have no possibility to, in fact, modify it. Meaning that what is registered in the blockchain is really what has been produced and what has been generated by this hardware oracle on the field. And this is where we need, in fact, to discuss and to extend the topic at EU, because in this directive from EU, which is 2018 and 2001, about the promotion of the use of energy from renewable sources, we have already the scope to generate some certificates, but as I say, some paper certificate with the kind of information you see on the top left here, where you have the energy source, the start and the end of production, the medium, all this kind of stuff. And these paper documents, in fact, can be generated directly by this hardware oracle from the site in order to generate the information to be stored in the blockchain and to be sure at the end that when you generate this certificate, you have a trusted entity at the beginning from the production site in order to generate it. Okay, I will go back, in fact, to other use case. I will get more questions for sure at the end. But another use case in order for you to understand better what, for example, is a smart contract. In your car today, you have your mileage. That is, in fact, something print on your car, but you are not able to trust it because someone is able to modify it in the car today. And when you are buying a car, you are not sure that what is on the screen is really what is the car has done. With this kind of hardware oracle, we are able to secure the information from the beginning and to register this information in the blockchain. And this information, for example, can be associated to a smart contract where the insurance is able to retrieve it from the blockchain, to trust it because it's coming from secure hardware, it's stored in the blockchain, and automatically create some action like giving you some token because you have respect. You are in line with what you sign with your insurance. For example, you say you are doing 10,000 kilometers per year, and this is possible to be checked by the smart contract and paid automatically to you by the smart contract when you are doing this kind of trust. This is where smart contract can be also automatic and can generate some new business case like, for example, this one around the mileage insurance. You are, in fact, ensured that what you see in the car is the reality and that your insurance can trust you because this information is in the blockchain. Another one, we speak already about that, provide public traceability of goods through secure assets to blockchain. If you have just seen, I think it's 2 days ago, the group LVMH, Louis Vuitton, in fact, have published the fact that they are working on the blockchain in order to ensure the security of all their assets and to ensure that when you are buying a Louis Vuitton bag, this is a Louis Vuitton bag because you are able to check the authenticity of this bag within the blockchain. And this is a project that has been announced, and this is the reality today. Louis Vuitton and others in this transport want, in fact, to protect their assets from the production and going to the distribution. And even after the distribution, when people are reselling things, they are able to check the fact that what you are buying is really what has been produced and it's not a fake product. Next, yeah.
Can you please use a microphone because the session is recorded, so your question will be recorded. Thanks a lot.
So, hello, Axel Simon from Red Hat. When you say blockchain, can you be a bit more specific? Do you mean a permission? Do you mean a non-permission public? Because otherwise, if a blockchain basically belongs to one entity, then there's no difference with a database. They can do what they want with it. So I was just curious about what blockchain you meant, for instance, in the insurance blockchain you were mentioning before, or in this case. Thanks.
It's what I said before. You can have two types of blockchain. What you say, permission, non-permission, meaning public or private. For example, in the Louis Vuitton, it's a private blockchain where you can access it through some website in order to check what is done. It's an hyperledger, if I'm right. fabric, in fact, blockchain. For insurance, after, you can in fact retrieve information if you are authorized to do it, for example, through a blockchain, through a smart contract, sorry. But most of the time, and it's where today, it's something also we need to explain to people. Going to blockchain mean if you are doing your own blockchain within your company and you didn't give access to people to this blockchain, you are going to do a database, a more secure database, but it's the same. If we want to extend the system, for example, to have a unique blockchain for Europe on this kind of transport or counterfeiting, it's something that needs to be more open and where people can get information in a public manner in order to avoid the kind of private things where it's difficult. Private is good, for example, when you are within your production center in order to check that, as it mentioned, the device during production is moving from one step to another, and at each time information are registered in the blockchain. This kind of stuff can be private, but if we are entering into, for example, green energy, this needs to be more open and more public. Next one about water quality. Soon you will see that Ledger have done a project with one of the major actor in this ecosystem in order to ensure security and privacy of data that are coming from sensor on the field, getting in fact the water quality. All around the quality of water is very important, and you need to have this information in a kind of public for you to check every day the quality of the water that are delivered at home, or for example for them to check the services and the quality of the water during some specific events. And this is where water is also a reality in this ecosystem of blockchain. You have also, I will say, a proof of concept in California, where they are in fact checking the quantity of water each vegetable producer in fact is consuming. And at the end, if the people are not consuming the full set of water that are authorized to them, they can exchange it with their, in fact, colleagues in order to have this kind of token exchange. If you consume it, you consume it. If you don't consume it, you are exchanging it through the blockchain with other people. And this in a way to share information and to share all this kind of stuff. And this will be the last slide from my presentation. Really, what is important today is to ensure, in fact, the data privacy from the beginning, from the origin of the data. And what we have seen, for example, with green energy is really where we need, as I will say, a market and a group, where we need, in fact, to go in order to provide information that are secure, information that we can trust within a blockchain, and information at the end that we know from where they are coming, and we can trust them in order to use it for the future.
I mean, you say ensuring data privacy in IoT ecosystem.
Yeah.
So I did not catch it, the data privacy, because I mean, IoT devices are devices. So where type of privacy are you referring to? No, because, sir.
Well, just to try to clarify, I think data privacy here means more the security of the data from an endpoint to another endpoint, and not data protection in the GDPR sense.
Then I think it's more about data. Then we should mention more about data protection rather than data privacy, because it's misleading otherwise. Thank you.
Let's go to question. Yeah.
Thank you very much for your presentation, especially in English. I'm going to ask a question for you and also maybe the professor back there. You guys both mentioning smart contract is the way forward, and smart contract is, as of right now, is a dumb contract, so it doesn't do too much besides what you write down. And you guys are doing quite with the cars, you know, sensors, you know, it's very, every country and every jurisdiction have their own. Is it all going to be in the smart contract? Because you cannot change what you put in the smart contract. So how are you going to go around it? I mean, 'cause it sounds good and it's probably going to pay off in the long run, but at the moment, how are you going to work around it? Thank you.
Around smart contract, I use some kind of example in order to explain what is smart contract. But smart contract today is really, in fact, attached to some blockchain, like the Ethereum, for example. And the Energy Web Foundation is using this kind of smart contract, but it's not the unique way, in fact, to manage the blockchain, because we know blockchain from different aspects are coming with their technology, their evolution, their specification. And yeah, maybe it's a mistake on my side to mention a lot smart contract, but it's not the only way, in fact, to do this kind of stuff. But it's just to explain it, in fact.
Have you looked at the Tesla gigawatt down in Australia? Because they're doing the same thing with energy coming to the houses, but they're not using blockchain, they're not using tokens. Do you see the difference there? Is that you guys can approve on that more efficiency because it's a very successful product?
I confirm it's a very successful product, but it's really only linked with Tesla. Meaning most of the time, the people that are producing energy and in fact storing energy in the battery they have on their home are using it to recharge their Tesla. And it's not today shared. If we are going to a shared model, I'm not sure they will continue to stay in this private environment. But fully agree, it's a very successful project, and it's something that prove, as I said, that some private solutions need to be are also efficient compared to public solution. Yes.
Thank you again, Michael from Logos. I think energy is a really interesting sector for the application of blockchain, mostly because of the challenges, because you have, despite a lot of good work at the EU level, as you represented there, there's really varying market conditions and liberal versus not very liberal regulatory landscapes for energy supply. In the UK, it's quite innovative, and in other member states, it's not so liberal, let's say, with lots of small players versus larger players. So I was curious how you saw such applications of blockchain being future-proof and a useful vehicle for changing regulatory conditions in the energy market, and maybe for the Commission as well, how they see the kind of infrastructure that they're looking to implement to facilitate that, and how it can be developed moving forward as market conditions change, as they shift towards more ambitious targets, and it opens up the market and so forth.
I will say, yeah, it's a promising market. Yes, it's today a little bit shared between the different entities, and what I have in mind, in fact, is to say that this proposal based on the EU we have shown is something that we can extend around Europe and to see how we can benefit of that. To mention another project that are ongoing through what is called the Trusted IoT Alliance, TIOTA. They are looking how to drive a car from, in fact, Spain going to Germany and using inside the different countries some place to charge the car, to get energy, sometime to sell energy from the car, sometime to buy it from different, in fact, actors. And this, for sure, need to be harmonized between the different countries. And this is where, for me, EU need to consider that and need to start to work on this use case. I will say that for me, it's the most mature use case we have seen on the market. Even if others are ongoing, it's more related to, like the LVMH project, it's more related to a company project. But at the end, it needs to be extended to manage it around Europe. But energy, green energy, it's already in place. We already have some directive from Europe, and we can extend it to add this kind of system inside.
Maybe one last question here from the audience. Yes, please.
Hi, Jesse, Jean-Charles Cabeguen from IExec. Thanks for the presentation. I have a question regarding the hardware solution you provide. What is the technical chip? What is the solution you have behind this hardware oracle?
Today, we are, as I say, we are using secure element from ST Microelectronics. Okay. This chip is certified. We'll enter in the detail, but EAL 6+, meaning that it's completely secure, in fact, in order to ensure the security of the information. And within Ledger, we have our own labs, security labs called the Donjon, which have done many type of attacks on this component to ensure the security. And also, we are using, in fact, algorithms which are secure in order to ensure that when we are deploying a device today, within the IoT, you are deploying a device today for the 10 next year, and we need to ensure that security now will be efficient for the future. We choose at the beginning the right components, but we also have the possibility to patch the component during the lifetime. This is all the kind of things we need to consider in order to ensure a long lifetime to the product.
Thank you.
Thank you very much, Arnaud, for your presentation. Please a round of applause for Arnaud.